Pictou is a new tool that is part of Epsilon, and it aims at supporting model visualization via model to text transformation. Okay, so just very quickly, Pictou is an Eclipse view for generating views from models through model to text transformation. It is part of Epsilon 1.6, which is the latest interim version of Epsilon, so it's something that you can download and try on your computer. All of these examples that will be demonstrated today are in the Epsilon Git repo under the examples folder, so you can check them out, you can reproduce them locally, you can edit them, play with them. So the way Pictou works is it uses model to text transformation to transform models, and these could be EMF models, or this could be any other type of models that Epsilon supports, into textual representations such as GraphViz, Plant UML, or even straight SVG, or HTML and JavaScript and Markdown. That can then be rendered and produce graphical views of these models. So I'm going to start with a very small example where we have an EMF-based, that's an EMF-based example. We start with a meta model of a social network that contains people, and then every person has a name, and they also like and dislike other members of the social network. And what we have on the left-hand side is a model expressed in FlexMI that conforms to this meta model over here. So we have 6 members of that social network, each of which likes and dislikes other members of the network. And what we have down here is Pictou. Pictou is a view in terms of the Eclipse terminology. And what we see is that it has 2 compartments. The left compartment is a tree of all the views produced by this model, and the right hand side is an actual instance of a browser, an embedded browser, where each view is rendered. In this particular example, we specify which transformation, which model to text transformation needs to be executed to visualize this model over here. So in line 2 of the model itself, we have the special processing instruction within FlexMI asking Pictou to visualize the model by running an EGX transformation that lives in this path, and to then populate this tree of views here. So what is the main appeal of Pictou? I think the main selling point is that in Pictou, meta models and model to text transformations and diagrams, they all live in the same workspace, in the same Eclipse workspace. So there's no need to spawn a new instance of Eclipse. You can create your meta models and your visualization transformations all within the same Eclipse workspace. And this is in contrast to existing tools such as Sirius or GMF or Graffiti, where you need to have your meta model in one Eclipse instance. You need to define your graphical editor in that Eclipse instance, and then you need to run a new Eclipse instance where you can have access to that graphical editor. And this is also the case with Sirius. Even though Sirius doesn't depend on code generation, you need to have your own design and your actual diagrams in different workspaces. And this can be fine if the main thing that you're doing is developing a domain-specific language. But if you are really just throwing together a small domain-specific language to solve a problem that you have in situ, then essentially migrating all your code to a new workspace where your DSL tools will now live, it can be quite inconvenient. So Pictou kind of provides this support for entirely reflective model visualization within the context of one Eclipse workspace. So in Picto, we can generate multiple views from a single model. So what we see here is for our social network model, we have produced 7 views. One is for the social network itself, so for the entire social network, where we see all the different members of the network and their like and dislike relationships, visualized as green and red edges. But we also have one small diagram for each member separately, and this will focus on that particular member and the people that they like and dislike, and will just omit everyone else in the network. So the way we generate multiple views is by using EGX. So if we look at the transformation that produces these views, we will see that we have this rule here called person to graph viz, which transforms every person in the social network into if you are familiar with EGX, you will not notice that there is no target here. So usually in EGX, every rule also has a target that specifies which file the outcome of the execution of the template will go to. In Pictou, we don't work with files. So in order to specify where the content of that will be produced after executing this template will be put, we have a number of parameters. The first parameter is the path of the diagram in the tree. So here you can see that when we run this template against, say, Bob, that will produce a view with a path social network Bob, right? And then Picto will take all these paths and will construct a tree out of them. We also need to specify an icon, and that's going to be a diagram with a kind of grayish header. We have to specify the format, because an EGL template produces text. In order to transform a text into this nice looking graph, we need to tell Picto what renderer to use, and in this case we specify that what this template produces is GraphViz code that needs to be rendered using the dot layout algorithm. We can also specify layers. So here we have 2 layers, likes and dislikes, and these we will be able to turn on and off from this button over here, and hide and show green and red lines. And we can also pass custom parameters like the people that we want to visualize, which in this case is just one person, the person on which this rule is invoked. We will go into more detail. That's like a quick preview of what Picto looks like. So what I'm going to talk about in this presentation today is some new features that we've been working on over the last few weeks. I'm going to talk about layers, how layers are actually implemented in Picto. I'm going to show you how we can navigate between views in Picto, how we can jump from one diagram to the other, but also how we can create hyperlinks from views back into model editors. Then I'm going to talk about the Picto configuration format, about how we can create custom views and how we can patch existing views and inject extra content, how we can compose views together and create views that contain multiple diagrams, for instance. And then I'm going to talk about the standalone mode of Picto, where Picto is not linked to any particular model editor, but it can consume several models, run the transformation, and produce diagrams. And I'm also going to show an example where we are using plant UML and Markdown instead of GraphViz to visualize models. So on to the live demo. So this is Eclipse with that social network model open here. So we can see the the diagram that we've been looking at so far, and this contains the members of our network and all their relationships. So this Picto is currently kind of bound to this editor. So, and it monitors the editor for save events. So if we were to create a new person called Helen that maybe likes Bob and dislikes Enid and Alice, and save, you can see how our diagram here gets updated. And we have, oh, come on. Right, so you can see how our diagram here gets updated, and we have an extra node for Helen and for the relationships to Enid, Alice, and Bob. We also have an extra item here, so we have Helen's dedicated diagram, and we can see the three relationships that we've specified in our model. It's worth stating that so let's actually have a closer look at the transformation before we talk about anything else. So our transformation consists of two rules. One that transforms the entire network into graph Vs, and it produces this diagram here that has a path social network. It produces graph Vs, but it uses the circle layout that graph Vs supports. So if I was to change this to say dot and refresh my diagram, we'd get a different layout because dot works in a different way than circle. Graph Vs supports a number of layouts, so we could go with FDP would produce a different layout, and things like Nito. So it really depends, and these can be further customized to kind of take the nodes apart. Which algorithm you end up using really depends on the nature of the diagram. I think Circo is quite a good fit for this type of for this size of network and type of relationships. Okay, so what did I want to say next? Yes, right, so we have these two rules here, network to graph Vs and person to graph Vs, and if you look closely you can see that they actually call the same template, right? They both call the social network to graph Vs.egl. The main difference is that, so here the people variable gets populated with all the people in the network, while here it's only a sequence of one person, the person we want to focus on. Let's have a look at the template to see how that works. So that produces the standard kind of preamble for a graph is graph, and then for every person in the people that we pass as parameter, we generate a node, and then if the likes layer is active, we generate the relationships, the like relationships. If the dislikes layer is active, we generate the dislike relationships. So if we look at the source behind this diagram, so Pictou has a nice convenient little feature where you can actually look at the source behind the diagrams that it displays. So if we look at the graph is source, you can see how we have one node for Alice, one node for Bob, one node for Charlie, and then the different likes and dislikes relationships. So remember, we specified layers here. So we said that there are two layers. They have this ID and this title, and by default they are active. So if I was to close the source view and then go to this button over here and say, well, actually I don't want to show dislikes, I just want to show like relationships, that would get rid of the red edges and relay out our graph. And we can do the same for likes and only be left with dislikes. These preferences persist when you move across diagrams. So if I was to change to Alice's diagram and go back to the network, the layers that I selected last time are still there. We can do the same, of course, with, well, that's not a good example because Alice is nice, only likes people. So, but we can hide, say, the dislikes relationships here, and we can show them again, hide the likes relationships. So this is really how layers work. It's not magic. You can specify what layers you want your diagram to have, and then use this. Where's that? So check if the layer is active within the generator of the diagram, and depending on whether it is or it's not active, change the kind of content that you produce. Okay, let's move on to a more complex example. So we've been working on a transformation that can visualize E-core meta models. So here we have a small example of a meta model. This is a component connector language, so you can see classes like components and ports and connectors and so on and so forth. And now we need to somehow tell Picto that we want to visualize this file, this E-core file, with Picto. We cannot change this file, we cannot embed this information in the E-core file. So what we need to do is we need to create another file next to it with the same name and the .picto suffix, which is really what instructs Picto to link this model with the Picto view and to update it every time this editor changes. So let's have a look at, I'll just get rid of all of that for now. So let's have a look at the Picto file. In its simplest form, it says that it will visualize the model that's kind of next to it with the same name but without the Picto extension using EGX, and it will use this particular template. So that's fine. If we save that and refresh, some stuff will disappear here. That's fine. So this is what we get outside of the box with this ecore.egx transformation. We get a diagram with all the classes in the model, and then we get, I will get better at this one day. Okay, and then we also get a HTML, JavaScript, a kind of Google Charts based graph of the number of classes in our meta model and the number of attributes and the number of references. This is just to demonstrate that views produced in Picto do not need to all be kind of graph based. We can make use of other frameworks, other tools that produce HTML to visualize aspects of our models. So here we have a class diagram which shows all the classes in the meta model, and you can already see how it's starting to get ugly. And here we have a 3D view of the inheritance graph of the meta model. Again, that's just to demonstrate that we can make use of all the different JavaScript, HTML libraries out there to visualize our models. We are not kind of constrained to just node edge visualization. Plus we get one diagram for each component, for each class of our meta model. So here we can see the class in focus being painted in green, and then around it we have the classes that it extends, and we have the classes that it has references towards. Plus we have all the constraints and critiques that are related to this class. Now, diagrams in Picto can be interactive in the sense that we can click on this diagram and that on this element, and that will take us to the diagram of named element. We have several layers in this transformation, so we can, for example, show all the different subtypes of a type, and we can kind of freely jump between diagrams, and we can also navigate to the editor where that class came from. So let's have a look. Let's see how this is all done. I think it's better if I just show the no, let's go to the template. So this is our transformation. So it produces this, it has a rule to produce this bar chart, and then it has another rule to produce this class diagram for all the classes in the meta model. And here you can see the different layers that we can turn on and off here. This is the rule that produces this 3D graph, and then we have another rule that is called for every class in the meta model and produces these little diagrams over here. Okay, so let's have a look at the transformation, the template. So the template that we use to produce this sort of graph is called class diagram. And it is quite an elaborate template. So if you look at it, it has about almost 500 lines of code, but it does several things. So let's have a look at how we bring in constraints. So if we look at our meta model, here we have an annotation where we say that constraints come from a file called comps.evl. If we open our evl file, we can see that our different constraints have a comment, and that this comment and the name of the constraint is reflected straight on our diagram. So if I was to change this and say, well, we're in component, we have this constraint called at least one port, so a component must have at least one port. So we could say a component must have one or more ports. And if I refresh here, you can see how that is reflected on my diagram. So really what we're doing in this template here is we have this method called getValidation module, which creates a new EVL module. It parses the constraints, and then it produces the actual nodes on the diagram. So this is to show that information in a diagram does not only have to come from within the model; it can come from peripheral artifacts as well, such as in this case constraints file. Now, how do we implement links? Let me search for JavaScript. Okay, so when we initialize this browser window, we really inject two JavaScript methods to it, and these JavaScript methods can be accessed by any renderer that eventually produces HTML. These two functions are called showView and showElement, and the showView receives the path of the view that we want to show, and this is what gets invoked when I click this link over here, right? This is how I move between the previous diagram and the new diagram. And then there's also the showElement method that receives the ID of a model element and the URI of a resource, and takes you to kind of any open editor that can show that URI and that model element. And this is what is invoked when I click on a green class. I said that I'm gonna keep an eye on the chat, but my other computer. Okay, let's see where we are. Are rules. So Patrick is asking if layers in Picto and SVG are the same thing. Not really. So in Picto, layers really get translated into conditional code that produces or doesn't produce some content. So it's not something that we generate every time and then we turn on and off. Actually, that's a good point. So if we look at the source here, at this stage, at the GraphViz source, you will see that we have GraphViz nodes for model element and model and component and type, because we visualize all of these classes. If I was to turn off the subtypes layer and we were to look at the generated source, you would see that we only have a label for named element. Okay.
Generated in SVG, you have this way of adding basically many layers to an SVG
yes.
Model, and then you can turn the visibility on.
Yes, Picto doesn't work in this way. It just doesn't. The transformation doesn't generate content that is not within that layer.
Okay.
Okay. So Sina is asking if the rules are triggered lazily. Yes. So when the Picto view is populated, only this tree is computed, and then these diagrams are only computed and rendered whenever we click on them on the view.
And are they cached once they've been rendered?
They are cached, yes, and they change only if their kind of base content changes.
Right.
Okay. So there have been two cases where EGX has been used as a parameter, render EGX and format EGX. Yeah. So what are the options? If we had a transformation that only produced one view as opposed to a tree of views, then we could use render GraphViz dot or render SVG directly. So if we're using a single EGL template, then the format is specified would be specified here. What is that? So if this was just an EGL file, we'd write as EGL here, and the format here would be GraphViz dot. Right? Because there's nowhere else to specify the format. But it turns out that in most cases, in most of the examples we've had to develop so far, we have been using EGX. Because with EGL, you're also limited in the sense that you cannot configure layers. So EGL, just straight EGL templates don't support layers.
Would it make sense to make the format parameter optional?
Yeah.
EGX?
Yeah, that's a very good point. Yeah. Okay, so I'll just make a note. EGX optional. Yep, very good point. Okay, so Betty is asking if the navigation is on click. You mean switching between the views? Betty?
I think Mike is muted.
Okay, yes. So yeah, this happens on click. So on click, Picto is instructed to move to that view, to port in this case. If it hasn't already produced the content for this view, it will run the EGL template, it will run GraphViz, it will produce the graph, and then it will show the graph. So everything happens on the fly. The very first version of Picto, we're just running the transformation and producing all the views in one go, but obviously this didn't scale very well for models with a large number of diagrams. Okay, so is caching implemented? Yes, they are. So views are only recomputed when something changes, and they are actually being displayed. So if I was to make a change to my meta model that would only affect the content of the component view, that would only be recomputed when I would actually select it. So not live captioning on Hangout. Yes, Evil, I've heard that before. Why not a built-in way to get the EVL module? I mean, in this case, EVL is specific to visualizing meta models. So we're not really running EVL against our meta model. We're extracting information from an EVL file.
Oh,
right.
Passing,
Exactly. We're just parsing EVL in order to show relevant constraints and their descriptions next to the classes.
so it's use case specific rather than...
Exactly. Now, this is one of the extensions that we would like to make to Picto, so that when you specify this Picto file here, where's that? Beyond specifying custom views, etc., which I'll demonstrate in a minute, you can also say, well, also run this EVL. And then that EVL would produce unsatisfied constraints and critique, which would get passed along to the rendering templates, and then they would make use of this information, in whatever way makes sense, depending on what they are producing. So they could add the error markers to the diagrams, or if we're producing tables, just plain HTML views, they could turn some text red to show that there is an issue. Yes, this is one of the extensions we'd like to make to Picto. Okay, good. Let's add our custom views here and refresh. So you will see that now I've added a bit more content in the Picto file, and that has produced a few more views. So let's have a look and see what these views are. So we have the first view here, which lives under path model custom core. So model custom core, and it's a class diagram. And so we specify this using this type parameter here, and whatever we put here needs to match the name of one of the EGX rules in the transformation. So here we have a rule called class diagram. We specify which layers we want to be active by default, in this case documentation, features, and inline references. And in this case I have turned on inline references so that we can see inline references here, because if I turn on reference labels, if I try to put this information on the edges, the diagram doesn't look as nice. So you can see, because the layout is auto-generated, in this case it just doesn't, it's okay-ish, but it's not great. I think it looks better if we just omit reference labels in this case. So here we specify that we want to generate a new view by running this EGX rule, and by passing it the following class names, so component, port, and connector, and this is why we only get these three classes here. I could change that and say, well, I also want to add type in here and refresh, and you see how this extra type node is added. So we can kind of create views with custom content in this way. What we can also do here is we can change the icon of a view. So if you see all diagrams here have a kind of white-ish diagram icon, this icon here is it's kind of magenta, I think. And the way we do that is by specifying this diagram stroke and then the name of a color. You can also use custom icons that live within your workspace for the different icons here. For example, all of these icons here, the class icon and the property icon, they just live within the workspace. They're all in here, and we can reuse custom icons for the views as well. Okay, so another thing we can do in views is we can patch the generated content. So here you see that we have this extra node, and this doesn't really come from anywhere in our meta model. This is just a custom GraphViz node connected to connector. So how do we do this? We specify a patch, and we specify that we want to run that patch at the level of the GraphViz dot representation, and then we specify some content for the patch. So let's have a look at the GraphViz dot representation. We'll go to the source. So this is what the template generates by default. So what we have in this patch file here, connected GraphViz patch, is so we try to match a line in the generated content that is just a closing curly bracket, which will match only this line. And here we specify that we want to add 2 more lines before that line. And if you are familiar with Dot, you will see that we are creating a new node called extra node, which has this label. Connectors will be represented as edges in the diagrams. And then we link that extra node to the connector node. So what happens is that our GraphViz is patched with the additional content, and we get this new node over here. If I was to go back to here and say, well, actually I don't want to apply this patch anymore, and refresh, then we'd get the same diagram but without that extra node. We can patch a view in several different, in any of the intermediate representations. So what we have here is another patch. Let me just put that back. So what we have here is another patch that will operate at the HTML level, because in order to get this view, we have to go from GraphViz to SVG and then from SVG to HTML, because eventually this is a browser, it only displays HTML content. So what we're doing here is we're patching the generated HTML with this patch. So core HTML.patch. Okay. If we look at the generated HTML, then effectively what we want to do is we want to get rid of this line, of this first line, and we want to replace it with a new line that also has this extra HTML string in here. Okay, so if I was to refresh my diagram, Listen, so we're patching here, fine, there's no layers. Okay, maybe I got this wrong. We'll get there. So that should apply to the first or the last HTML. Anyway, yeah, okay, forget about this patching, but the HTML patching. Let's move on. I'll need to figure that out later. What can we also do? We can also create views with static content. So here we have this model readme HTML view, and if I click on it, you can see that it has some HTML content, it has some CSS styling, but it also refers to other diagrams generated using Picto. So we can see this connector class diagram, which is this one, and this component class diagram, which is this one. And then if we were to modify our meta model, and then do this at the emphatic layer rather at level as opposed to eCore. So if we were to go to connector and add another attribute, and save, you can see how this composite view is also updated, how we get the extra attribute here. So how does this work? How can we reference other views from within Picto views? Let's have a look at this readme HTML. So here we have just standard HTML. We have the title of the page here. We refer to a CSS file which lives next to our HTML, and we have some text. We can use the show view method here. So if we wanted to, this is the JavaScript method that gets injected by default into the Picto browser window. So if we wanted to move to our markdown version, I could click on it and we switch to that view, go back to my HTML version. And then we also have this custom element called Picto view. And here we can specify the path of a view, and Picto will include it in the place of this custom element within the generated view. And we can also we can do this for any view that Picto produces. Let's see if there are any comments. Okay. Yes, figuring out what's built into Picto and what needs to be implemented. Yeah, that's a good point. Okay, I've made a note of that. And patch seems to require a deep knowledge of the internals of Picto. Not really. It requires an understanding of the generated representation that you want to patch. So if you want to patch a representation, all you need to do is you need to look at the source code of the level you want to patch, and then figure out how you want to change that code, how you would change that code manually, and then just write a patch that does the same change automatically. Patching is quite brittle because, as you saw here, if something changes in the representation, in the base representation, then the patch will not apply and you will not get your customization. So patches are really just for like fine-tuning diagrams before you copy and paste them and throw them in a report, for example. Okay, right, so we have our patches here. We talked about these custom elements. And what else is there to talk about? Yep, we can also patch existing views. So here we're taking this model classes component view, and we're just changing its icon. We don't touch its content. And here we have another example where we're patching a generated view at the kind of graph viz level. And this also demonstrates another parameter, so we can specify conditional patches, because depending on what you show, depending on which layers are enabled, the different content will appear in the view, and patches may only make sense if certain layers are visible or if they are invisible. So applies really gets an EOL expression where the names of layers are turned into booleans, and we can do things like reference labels or inline features, inline references, for example. And this will get evaluated, and based on whether one of these two layers is enabled, the patch will apply or not. Okay, and I think we're kind of running out of time anyway, so I think that's... I see a question. Would it be better to patch the EVL at the EVL level? There is no EVL level. So if we look at the different levels here, we have the graph viz level, because our rule produces graph viz. Then there is a transformer that transforms graph viz to SVG, SVG to HTML. EVL, we only get content from EVL during the transformation. It's not a separate kind of transformation step. Okay, so going back to the slides, just to close with some ongoing and future work. So Alfonso has been working a lot on change visualization. So since we now have this nice rule-based way to produce diagrams, to produce views from models, what happens when these models change? And the idea is that we're trying to compute essentially a delta of the view tree with only views that have been affected by this change, and also show the changes in a sensible way. We're also looking at views with editable layout. So Alfonso has implemented a clone of the eCore visualization transformation that makes use of joint.js instead of GraphViz. So very quickly, because I meant to demo that very quickly. So here we have our meta model, and we can move things around in the view, because this is built using joint.js instead of GraphViz. There are other challenges there, but we don't have enough time to get into these. The point that Sina made about integrating model validation, yes, that's something that we should be able to configure in the Picto file to say, well, before you attempt any transformation, try to validate the model. Maybe if certain constraints fail, visualization could be aborted because these are kind of core properties of the model that don't hold, and maybe our templates will break, or whatever unsatisfied constraints are produced, they just get forwarded to the templates to visualize them in whatever ways make best sense. And then, because Picto is based entirely on web technologies, it would be nice at some point to create a web application so that we can produce these visualizations. We can allow people to explore models from a browser without needing to have Eclipse. Okay, and I think that's everything.